Endeavor ISS, this is Houston. Are you ready for the event?
We're ready.
University of Arizona, this is Houston. Please call Endeavor ISS for a voice check.
Hi, this is Mike Drake at the University of Arizona. Can you hear me?
Yeah, Mike, we got you loud and clear. Welcome aboard. We're on board the Japanese module on the space station right now.
Well, as you can hear, there's a lot of applause in the room. We have a lot of different people here today. We have staffers and friends from your wife, Congresswoman Gabby Giffords' office, who are with us. We have a number of first responders from the fire department that are with us. Most importantly for us, I think, is we've got a lot of middle school students who are going to be the ones asking you questions. And we also have a number of University of Arizona space grant students, which your wife Gabby has been very strongly supportive of, a great program at NASA. So let me get right to it. I appreciate you taking time tonight, Mark, and your two colleagues. Do you want to introduce the other two colleagues with you so that the people in the audience know who they are?
Yeah, absolutely. To my right, your left, is our pilot, Greg Johnson, Air Force Colonel, just retired. And on my left, your right, Ron Guerin, who is the U.S. Segment Commander of the International Space Station. He's been on board here about, what, 7 weeks now?
Great, thank you very much. Let me bring up our first middle school student. I'm going to ask her to say her name and ask her question.
Hi, my name is Lena Arriaga from Gridley Middle School. My question is, what feeling did you have when you first looked out the window?
Well, let me first say, you know, for everybody there, welcome aboard the space station. It's a great opportunity for us to have a chance to talk to the folks there back in Tucson. I know I probably know some people in the office. We can't see you, but you know, it's nice to have the opportunity to do this event. We just got up. I imagine you guys are getting ready to go to sleep this morning. Or this evening. With regards to your question, though, for me, when I first saw the Earth, it was over 10 years ago. I very distinctly remember it. I was the pilot on the same space shuttle that's docked just a little bit to out that hatch and to our left, Space Shuttle Endeavour. And at Mach 15, when you're going into orbit, the space shuttle rolls to heads up, so it's upside down and it rolls heads up. And I looked over my right shoulder out the window. You could see this big blue planet out there, and it's really like, even though it was 10 years ago, it's like it was yesterday. Very, very spectacular view. And it's pretty exciting to get to go into space.
I'm going to add to that answer only because I experienced my first daytime liftoff about a week and a half ago, and to my left was Commander Kelly, and I was the pilot in the right seat, just like Mark was recalling from 10 years ago. My first flight was 3 years ago, and it was at night, and so this past launch was my first day launch as well. And looking over my right shoulder, I was amazed at how the Atlantic Ocean accelerated by. I do recall looking out the window and Mark said, "Focus," because as the pilot, I'm supposed to focus on the engines and other systems. But I was amazed at what it looked like out the window. So I just wanted to share that with you.
Thanks so much. It's nice to know you're human as well as highly talented and trained. Next question, please say your name.
Hi, I'm Alex Boland, and do you have to tie everything while in space or during liftoff and landings?
Well, hi, Alex. Yeah, we really do. When on launch, everything vibrates and shakes, and so everything has to be tied down. But once we get to orbit, it's not shaking and vibrating anymore. But if we don't tie it down, it'll float away. So, one of the big challenges living up here is not losing your stuff. So we have to keep things tied down, keep things secured, because you'll lose it pretty fast. But that becomes challenging, but it also becomes fun too. So if you're eating a meal, and you have a couple of things in your hands, if you run out of hands, you could just take your food and stick it right there, and then go about getting a drink or something else, and then just grab it, and there it is. Okay, just like that. So so it's it's challenging on one hand, but it's a lot of fun on the other.
Sounds like very convenient and better than growing another arm. Next student, please. Say your name.
Hi, my name is Bailey Bishop from Gridley Middle School. My question is, how are you adjusting to zero gravity?
Yeah, I think the first time you fly into space, it takes a while to get used to it. There's no up and down anymore, and it's hard to manage your stuff, and the fluid shifts in your body, so you don't feel too well. The more you do it, the easier it gets. It seems like, for me, this is my 4th flight, and it seems like my body remembers what this is all about and understands it, and I can get adjusted quicker. Space station crew members tend to say it takes about a month till you're really adjusted on orbit. I've never been in space for a month at a time, so I can't really comment about that.
Thank you. And the next question. And name.
Hi, my name is Mia Birch from Gridley Middle School. My question is, why do you take dry food with you, and can you eat regular meal in space, or is it impossible to keep the food from floating off?
Well, we have Velcro attached to all our food items. Mark just grabbed, looks like some dried fruit of some kind. Dried pineapple. We have a lot of dehydrated foods like dehydrated pineapple, and we have other items that come pre-packaged, all ready to go, and they're in packets that we just put in the oven and heat. We also have clear packets, plastic packets that we inject water in to rehydrate them, and every meal is fun. So it's really easy to eat, and the food is great. Some people love the shrimp cocktail. I actually prefer the M&Ms, and it's a normal diet. I made a hamburger the other day. Since it's zero gravity, I was able to stick a tortilla on a clip, put a little ketchup and mustard. It doesn't go anywhere, and then I stuck the hamburger patty right on the ketchup, and it stuck because, of course, gravity's not acting on it. And after I took it off the clip, I rolled it up and ate it. So we have pretty much normal foods, no soda pop or things like that.
Moving on. Thank you. That looks like fun. Next question. Give you a name.
Hi, my name is Alex Enriquez from Gridley Middle School. My question is, how long does it take to readjust when you get back to Earth?
Well, Alex, that's a good question, and a lot of it depends on how long you've been up here. For shuttle crew members that are up here for maybe 2 weeks or so, the readjustment is pretty quick, maybe a few days. I remember on my shuttle flight about 3 years ago, I think it was probably a day or two before I could walk without thinking about it. And I remember when I first got back, I would take a step and go, okay, there goes the left foot, there goes the right foot. I'm starting to lean left. I need to lean back right. And so, but that passed very quickly. For station crew members who are up here, maybe 6 months, the rehabilitation is much longer. And some of the things that we do to help prevent or to make it so that when we get back we don't have such a big adjustment period is exercise. And we do 2 hours a day of either resistance exercise like weightlifting or aerobic exercise like riding the bike or running on a treadmill. And that really seems to help. It helps us in our adjustment when we come back to Earth, and it also helps prevent some of the or slow down some of the processes of just living in space, like losing some of our bone mass and our muscles weakening and things like that. So it helps to counteract that. So there's a big, long period of time after we get back where we slowly, do a lot of exercise and a lot of other activities to readjust to gravity once we get back.
Okay, and our next question from...
My name is Shay Bushy, and I'm from Gridley Middle School. My question is, how do you sleep in space?
Well, you know, you could sleep just kind of floating around. The problem with that is you'd bump into other people and you'd wake them up. And then you might not have any idea where you're going to go to on the space station. It's a really big place. So what we do is we sleep in a sleeping bag. It has a bunch of straps and hooks, and you can tie it to the ceiling or to the floor or the wall. Last night I slept on the floor of the flight deck of the space shuttle. Mike Fink, one of our crew members, was sleeping on the wall downstairs, and sometimes people will sleep on the ceiling. It takes a while to get used to sleeping in zero gravity. There's no pressure on your body. My first night in space 10 years ago, I got in my sleeping bag, and then I immediately rolled over on my side like I would in bed, and then thought to myself, well, this is kind of dumb because there is no side, because there is no up or down. So you might as well just stay in the position you're in.
Thank you. Oh, did you have last year?
Hi, my name is Kirsten Bassett, and I'm from Gridley Middle School. My question is, how is growing plants in space different from growing them on Earth?
Kristen, that's a really good question because we're actually doing that. And we're trying to figure out the answer to that question, really, and, what effect gravity has in how plants grow. And one of the things we're trying to do is remove, because we're in space and because we're in this what we call microgravity environment, we can eliminate gravity from the equation, and we can see how plants grow without gravity, and that helps us to better understand the process of plant growth, which helps us understand how crops grow and how we can make more food. And so one of the things that we're doing is we're looking at what factor gravity plays in a plant's growth and how that compares to things like moisture in the soil and chemicals that are used for fertilizers and things like that. And a lot of the research that we do is so that we can go farther and farther into space. And, when we go to Mars and beyond, we're going to have to grow our own food in order to do that. And so that's a very important part of the research that we do up here. But on the one hand, we're trying to discover how to go further in space, but we're also helping, all the people on Earth as well as we grow, figure out how to grow crops in areas that are stricken with drought and, areas that don't have really good soil. And so there's a lot of experimentation that we do to look at the effects of gravity. And we also have, cameras on the space station that look at crops throughout the world and evaluate how they're growing over time so that we could better understand that process. So very good question. Thank you.
Hi, my name is Nora Thompson from Gridley Middle School, and my question is, how can you create gravity on the space station?
If you've watched any science fiction movies, you might have seen rotating spaceships, large rotating spaceships, and that would really be the only way that I can think of to artificially create gravity. We really don't know exactly what gravity is, so that's one of the problems, but we do know that by rotating a large object, we can create the sensation of gravity. Now, the space station, although we're pretty much stationary in space with relative to the Earth, so we feel pretty much zero gravity, we are slowly rotating as we orbit the Earth every 90 minutes. And so one of our fellow comrades, an Italian astronaut, he can actually sense that feeling where one side of the space shuttle has just a little bit of a drift up and way at the far end, and the Russian side it has a little bit of a drift down as we gradually rotate around the Earth. So I would say we possibly are experiencing that now. Some of us don't necessarily believe that's true, but if you really rotate the vehicle quickly, we'd be able to kind of have an artificial sense of gravity.
Hi, my name is Emily Jonathan from Gridley Middle School. My question is, what do you do with waste in space, and how do you recycle in the shuttle?
A space shuttle mission's only about 2 weeks long. We're going to land on flight day 17, so we bring home all our garbage. It gets recycled on the ground. We separate it a little bit just because of areas. We want the wet stuff together and the dry stuff in a different spot. But on the space station, they've got a bigger garbage problem, so I'm going to turn that over to Ron. Maybe he's got some comments.
Well, some of the garbage, like just the things that we make, like packaging material and leftover food and stuff like that, we actually have cargo ships that come up and deliver goods to us, and then when they go back to the Earth, they actually burn up in the atmosphere. And so before they leave, we pack them full of as much garbage as we can. But on a space station, it's very, very expensive and very difficult to bring up supplies. So whatever we can produce ourselves, we want to do that. So water, for instance, it's very difficult to bring up water. So the water that we have, we want to use over and over again. And so when we go to the bathroom, the urine that is captured by our toilet, basically, is recycled. And some of the condensation in the air that the air conditioners capture is also recycled, and then we drink that. So it's an interesting process. And again, when we go farther and farther in space, we're not going to be able to launch with as much water as we'll need to go to Mars, for instance. So we'll have to recycle that.
Hi, my name is Leo Morales from Gridley Middle School. My question is, why are the space shuttles and space stations so white?
Do you mean, like, why is it the space shuttle white on the outside?
Yeah.
Yeah, I don't know. I imagine it has to do with, when we designed it early on, we designed spacecraft, and we made the Saturn a white rocket. It certainly could be a different color. When you're outside of the Earth's atmosphere and in the sun, it gets really, really hot, and in the shade, it gets really, really cold. So I imagine because of the thermal properties and the need to reject heat inside the space shuttle, we also have a lot of electronics that make heat. So you want the outside to be a little bit on the cooler side so you don't have heat buildup. So that's probably why we chose white as the color. If you notice, black pavement there in the summer, especially in Tucson and in Arizona, where it gets really, really hot, that stuff is a lot hotter than the white stuff. So white would be a good choice. The space station actually isn't white on the outside. A lot of the panels are aluminum. Part of the Russian segment is kind of white. It's got solar arrays that are orange. Sometimes they look a little bluish, and some radiators. So the space shuttle's more multicolored. The original ET was white. Yeah, we also made the original external tank. We painted white, and I don't think we had even a good reason to do that. Eventually, we took the paint off to save weight. It was about 1,000 pounds, I think, of weight, and now it's orange.
Hi, my name is Amanda Duncan from Gridley Middle School. My question is, can you see signs of man-made or natural disasters from space?
Amanda, you can, and that's one of the really good things about being up here and having this vantage point to see our planet from. And one of the most recent ones is the flooding in the Mississippi River, and we were able to take pictures of that and kind of document over time the changes to the river and the effect in the surrounding communities. And so, volcanoes, hurricanes, pollution, all those type of things that are affecting our environment, we can monitor, we can watch, we can keep track of up here, and it's really interesting to see that and to see the good things and the bad things, and see how man-made effects on our planet are making some changes that some of them good and some of them bad. So it's good to keep track of that, and it's a wonderful place to do that from.
Hi, my name is Jessica Luna from Gridley Middle School. My question is, what is a typical day like on the space shuttle?
Well, a typical day on the space shuttle is we all have a particular wake-up time. Right now, our wake-up time is about 12 hours shifted away from yours. We just woke up, and you're probably starting to think about going to bed tonight. Once we get up, we have a couple hours to ourselves where we shower, brush our teeth, shave, we get something to eat, get a cup of coffee, although it's not really a cup, it's more like a bag like this. And then we look at our schedule for the day. On the space station, they're given a schedule. We're also given a schedule on the space shuttle, and we do our various tasks. They might be spacewalks. They might be filling a water bag. They might be operating the robotic arm, or it might be moving water from one place to another. But we have various tasks. They allow times for meals. They allow times for exercise. And then prior to sleep, we have another couple hours that we can kind of get our stuff together, get a little free time, look out the window, and then we go to bed. On the space shuttle, most of our schedule is very, very regimented and structured and busy for the entire time we're here. We kind of compare it to like a sprint, a fast-running race. Whereas on the space station, and I've never been assigned on the space station, because they're going a little bit longer duration, I think they do get a few weekend days off now and then. With just Ronnie here, I'm sure he's not going to get as much time off as he wants, but they view that more as like a marathon. And so that's pretty much a typical day in space.
Hi, my name is Chris Kryzik from Gridley Middle School, and my question is, do you exercise or run in space?
On the space shuttle, we have a bike, and I'm actually scheduled to ride the bike here in a few hours. Helps us not lose as much bone mass and be more adjusted for entry, which for us is actually just a few days from now. On the space station, they've got more options. They have a treadmill with some straps to give you some gravity, so you're strapped to the treadmill. There's also a bike, and there's a resistive exercise device which allows you to lift weights in space. Nothing has any weight, but this device seems pretty much like you're lifting weights, like at a gym. So there are options on the space station, and like Ron said earlier, the space station crew members are assigned to exercise about 2 hours a day, so after 6 months, when they get back, they're not in too bad of shape.
Hi, my name is Taylor Reynolds from Gridley Middle School. My question is, how does the human body change in space, both long and short term?
Well, the human body is an amazing thing, and it really adapts very quickly to any environment that it's in. And very quickly after you get to space, your body starts to adjust, and that's a good thing. But some of that adjustment is not that good. So one of the things that your body realizes is it doesn't really need a skeleton anymore, and so you start losing a lot of the mass in your bones, the density of your bones. You don't need the muscles in your legs as much, so you start to lose those. As Mark said, the fluid shifts. So in your body, there's fluid that is all kept towards your feet because of gravity. So once you get to space, that is free to flow to different parts of your body that it normally doesn't. So those are all changes that occur. Your eyes change shape. So there's a lot of these different effects that occur as your body tries to adjust to its new environment. And like we had talked about before, so, some of these bad effects, like losing bone density, we have to counteract through other means, like exercise. So, like I said, the body is an amazing adaptive thing, and it's something that we study up here a great deal. We have a lot of experimentation that we use, that we do on ourselves and on each other as crewmates, and we are learning more about the human body with our time up here.
Hi, my name is Jonas List from Gridley Middle School. My question is, what is astronaut training like?
It varies a little bit between the space station and the space shuttle, actually pretty significantly. For a space station crew member, you're training to be on an expedition for a very long period of time and operating different laboratories aboard the space station, as well as the space station systems that keep you alive and recycle urine into water like Ron was talking about. On the space shuttle, it's more like, it's a ship, more like maybe a ship at sea, but an airplane, the combination of the two. It has environmental systems for life support, but it also has the systems that an airplane would have, as well as a robotic arm to do robotic arm operations. The space station has this as well. So we got to learn about the systems, and we got to learn how to operate them really well, particularly on liftoff and landing. It's very dynamic environment. Things can happen very fast. Things can break. So we spend a lot of time in space shuttle simulators practicing to handle things when they go wrong. So Greg and I here have spent probably thousands of hours in the space shuttle simulator during liftoff and landing. For the space shuttle, we also have to practice landing it. We practice spacewalks. We had 3 of our crew members do 4 spacewalks over the last week or so. They spent a lot of time in a very large pool in the spacesuit that provides some neutral buoyancy, so it's similar to the spacewalk. We practice robotic arm operations. We're in a classroom, kind of like you guys might be at your middle school. So it's very varied. And it's really a great job.
Okay, Mark, I'm told we have time for one last question. So here's the last one.
Hi, my name is Maddie Shaw from Gridley Middle School. My question is, how do you shower in space?
Well, thanks, Maddie. We don't have a shower. Skylab, after the Apollo program where we went to the moon, actually had something that was like a shower, and I think worked pretty well. On the space station and space shuttle, we don't. So we take a bath kind of like somebody would if they were in a hospital bed. With a towel and water and soap on it. You rub it on yourself, and then you wipe it off later. So it's not the greatest shower, but it works. It works for 2 weeks for us, and it'll work for 6 months for Ron. So that's a very good question. Before we go, I wanted to congratulate the University of Arizona on their new project, and I can't remember the name of it. We just saw it in the news since we launched on the 16th of May, but their project to visit an asteroid. That's very exciting. It's, I think, one of the biggest NASA-related projects that a university has had, and so I wanted to congratulate the University of Arizona for that milestone in their exploration of space. So thanks very much, everybody. It was great talking to you today, and hope to see you in Tucson.
Thank you, Mark. Let's all applaud their work up there.
We're going to fly out of the way here.
Safe travels.
You're welcome.
Endeavor ISS, this is Houston ACR. Thank you. That concludes the event.
Thank you, University of Arizona and participants.